Okay, so this lesson is going to review and introduce acids and bases for you. So we have this picture here with several different acids and bases. So what I want to do first of all is just highlight all of the acids in one color, just so we can bring some attention to it. So here's all of my acids. And then I'm going to highlight all of the bases another color. Only two bases. Okay. Alright, so then we're going to start using these pictures to answer our questions down below. So number 1 says, what ion is present in all the substances labeled as acid? So when you look at the pictures here, the acid or the base has dissolved or dissociated rather into the ions that are present in there. So when you look at all of the acid pictures, you notice that all of the acids have these H plus ions, okay? They all have different kinds of anions, but they do all have H plus ions. And I know I'm not highlighting all of them. I'm just highlighting some of these just to bring some attention to it. So all of the acids have H+. So that's what I'm going to put as number 1. When I look at number 2, what ion is present in all the substances labeled as a base? So I look at my two base pictures, number 4 and 7, and the bases both have these OH ions. They have a different cation, a different positive ion, but they do have those negative OH hydroxide ions. So I'm going to put OH negative for question number 2. Number 3, which ion is absent in all the substances labeled as bases? So I look at pictures 4 and 7 again. Try to see what ion is absent. Well, the thing that I highlighted with the acids, the H+, that's actually absent in the bases. So number 3 is H+. And then number 4, which box is neither an acid nor a base? That's the one that we didn't highlight, so that was box number 3, the water. So, when it asks, why is that substance not acidic or basic? I mean, when I look at that picture, when I look at number 3, it has H+ ions, and it also has OH negative ions. So why is this considered not an acid or a base? Because it has equal amounts. It has equal amounts of hydrogen ions and hydroxide ions. Okay. Number 6. Write the formula of each acid in the space underneath the appropriate boxes. Don't forget to drop and swap. So we have to drop and swap. So here, when we look at our ions that we have present, we have H+ ions, and we have SO3 -2 ions. So when we drop and swap, that formula would be H2SO3. For this box number 2, we have H+ ions, and we have Cl -1 ions, so dropping and swapping would give us HCl. This one's water, so we know that's H2O. Number 4, we have Na+ ions and OH -1 ions, so dropping and swapping would give us NaOH. Number 5, we have H+1 ions and Br -1 ions. Dropping and swapping gives us HBr. This one we have H+ ions and NO3 -1 ions. So we would get HNO3. This one we have NH4 +1 and NO3 -1. Remember, I didn't mention this before, but the cation, the positive ion, always gets written first. That's why I've been putting the positive ion first. So dropping and swapping would give us NH4NO3. And then last, we have H+ ions and PO4 -3 ions, so that would give us H3PO4. Okay, if you forget how to drop and swap, you might want to look. So we finished number 6. So number 7, what do you notice about all the names of acids containing only 2 types of atoms? So the ones that have 2 types of atoms, well, that would be number 2, because it only has H and Cl. So here's the name. Then number 5, because it only has H and Br, so that's this. Everything else, all the other acids have more than just those 2 atoms, because this one has H and NO, this one has HS and O, this one has HP and O. So the names for those, when you look at the names, that's what I circled up here, hydrobromic acid, hydrochloric acid, those names have hydro prefix. So those ones have a hydro prefix. Okay? The other acids don't have that hydro. I forgot to auto lock this. Let me see. Okay, that should be better. So then let me get the next page so we can finish these questions here. What do we notice about the names of the acids containing 3 or more different types of atoms? So we've got this one that has H, S, and O. We've got number 6, which has H, N, and O, and then number 8, which has H, P, and O. And it says that's different from the acids with only 2 types of atoms. So the difference here is that these ones do not use hydro as a prefix. Now, why do these all have 3 different atoms in here? Because these ones have polyatomics. Just pointing that out for later. So polyatomic ion is present. All right. So then number 9. Boxes 1, 6, and 8 all contain acids with 3 different atoms. How does the name of box 1 differ from the name of boxes 6 and 8? So we're comparing 1, 6, and 8. So sulfurous acid, nitric acid, phosphoric acid. This one ends in OUS, this one ends in IC, and this one ends in IC. Okay? So for number 9, the ending of box 1 is US, and the ending of boxes 6 and 8 is IC. So now we have to come up with some rules. So why does number 1, sulfurous acid, end in US, and the other ones, nitric and phosphoric, end in IC? Well, I did put a little note up here that the polyatomic ion is present in these 3. In boxes 1, 6, and 8, the polyatomic ion is present. So it's got to be something about that polyatomic ion. So let's see if we can find those. So the sulfurous acid had SO3 -2. So here's SO3 -2, the sulfite ion. The number 6 nitric acid had NO3 -1. So here's NO3 -1 nitrate. And then box 8 had PO4 -3, which is this one. So when we look at those 3 ions that are present, nitrate, phosphate, and sulfite, here's an 8, here's an 8, here's an ite. These ones ended in IC, and this one ended in US. So that's going to help us write our rules. So we've got to make 3 rules. I don't think it specifies 3, but let's make some rules. So rule number 1. If the hydrogen ion is present with one other atom. Use hydro and end in ic. So those ones, if the H plus is present with one other atom, we use hydro and it ends in ic. So for example, HCl, hydrochloric acid. Okay? Just two atoms present. So then, if you have H plus paired with polyatomic ions, no hydro. And then we have two things underneath here. If the polyatomic ends in 8, the acid ends in ic. And then if the polyatomic ends, oops, I don't know why I put an extra I there, ends in ite, the acid ends in us. Alright, so when you're going from the name to the formula, you want to see if there's a hydro or not. So no hydro means it has a polyatomic ion. The fact that it ends in ic means that the polyatomic ion ends in 8. So we're looking for nitrate. So here's nitrate, NO3 negative 1. We drop and swap to write the formula. So it's H plus and NO3 negative 1. So it's HNO3. When you're going from the formula to the name, look to see how many ions it has. It has 3 atoms in there, so it's got a polyatomic ion, which means no hydro. So we look at ClO3. Here's ClO3. ClO3 negative 1. It ends in 8, so that means it's going to end, and that ending switches to ic. So this would be chloric acid. This one, way more than just one atom. Okay, so we want to find this polyatomic ion here, C2H3O2. C2H3O2 right at the top. Acetate. Remember, if it ends in 8 on the polyatomic ion, the acid ends in ic. So this becomes acetic acid. Sulfurous acid, there's no hydro, so that means we have a polyatomic ion. The ending of us means that the polyatomic ion ends in ite. So we're looking for sulfite, which is down here. So we have H plus with the sulfite ion, SO3 negative 2. So that means our formula is H2SO3. Hydroiodic, prefix of hydro, means that it's just two atoms. That means it's the hydrogen, of course, with whatever this is. That root name tells you what element it is. So iodic means that it's iodine. So dropping and swapping gives us Hi. Here we've got just 2 atoms. So that means we're going to start with hydro. And then the F is fluorine, so we just change the ending to ic, so fluoric acid. This one, we've got more than 2 atoms, so it's a polyatomic ion over here. We're looking for PO4. Here's PO4 here. It means we have phosphate. The 8 changes to ic, so we have phosphoric acid. Carbonic acid, no hydro, means that we have a polyatomic ion. Ic means that it was 8, So carbonate, we're looking for carbonate. Here it is. It's CO3 -2. So that means we have H plus and CO3 -2. So dropping and swapping gives us H2CO3. And then the last one, HCl, just 2 atoms. So that means we start with hydro. The Cl means that it's chlorine, so it changes to ic, so chloric acid. And then number 12, it represents a solution of salt water. Would this be acidic, basic, or neutral? Why do we think this? So I'm going to let you guys take a look at this and see what you think. Let me know what you guys think. I'm interested to see if you can figure this one out. Okay? Let's do the practice for the naming of the acids on page 6 in your packet, and let me know how you do. I'll check your work. Bye.